Welcome to this comprehensive guide on linear equation forms. Today we'll explore one of the most fundamental topics in algebra, understanding and converting between different forms of linear equations. Before we dive into the different forms, let's establish what a linear equation actually is. A linear equation is any equation that represents a straight line when graphed on a coordinate plane. The key characteristic is that the highest power of any variable is 1. There are three essential forms of linear equations that you'll encounter regularly in mathematics. Each form has its own advantages and specific uses, depending on the information you have and what you're trying to find. First, we have slope-intercept form, written as y equals mx plus b. This form immediately shows us the slope of the line, represented by m, and where the line crosses the y-axis, represented by b. Second is point slope form, written as y minus y sub 1 equals m times the quantity x minus x sub 1. This form is perfect when you know the slope and any point on the line. Third is standard form, written as ax plus b equals c, where a, b, and c are constants. This form makes it easy to find both x and y intercepts and is useful for solving systems of equations. Understanding these forms and how to convert between them is crucial for several reasons. First, it allows you to solve real-world problems more efficiently by choosing the most appropriate form for the given information. Second, different forms reveal different information about the line, so knowing how to switch between them gives you flexibility in your problem-solving approach. Finally, mastering these conversions builds a strong foundation for more advanced topics in algebra, geometry, and calculus. In this comprehensive series, you'll first understand each form's unique advantages and when to use them. Then we'll master the conversion techniques step by step, practice with guided examples, and apply these conversions to solve real mathematical problems. By the end of this series, you'll have complete confidence working with all three forms of linear equations and converting between them fluently. Are you ready to master linear equations? Let's begin. The slope-intercept form is one of the most useful and intuitive ways to write linear equations. It immediately reveals two crucial pieces of information about any line: how steep it is and where it crosses the y-axis. The slope-intercept form is written as y equals mx plus b. This simple equation contains everything we need to understand and graph a linear relationship. Let me break down each component. The letter m represents the slope, which tells us the steepness of the line. The letter b represents the y-intercept, which is the exact point where the line crosses the y-axis. To truly understand slope-intercept form, we need to see how it works on a coordinate plane. The visual representation makes the concepts much clearer. Here we have our coordinate plane with x and y axes. This is where we'll visualize how slope-intercept form translates into actual lines. Our first example is y equals 2x plus 3. From this equation, we can immediately identify that the slope m equals 2 and the y-intercept b equals 3. The slope of 2 means that for every 1 unit we move to the right, the line goes up 2 units. The y-intercept of 3 means the line crosses the y-axis at the point 0, 3. First, we plot the y-intercept at the point 0, 3. This is where our line begins. From the y-intercept, we use the slope to find the next point. A slope of 2 means we go right 1 unit and up 2 units, bringing us to the point 1, 5. Now we can draw the complete line through these points. Notice how the line has a positive slope, rising from left to right, and crosses the y-axis exactly at 3. Now let's examine a more challenging example with a negative slope to see how the pattern changes. Our second example is y equals negative 1/2 x plus 4. Here we have a negative slope of negative 1/2 and a y-intercept of 4. A negative slope means the line falls as we move from left to right. The fraction 1/2 means we have a gentler slope than our previous example. We start by plotting the y-intercept at 0, 4. For a slope of negative 1/2, we can think of it as negative 1 over 2. This means we go right 2 units and down 1 unit, taking us to the point 2, 3. Drawing the line through these points, we see it has a negative slope, falling from left to right, and crosses the y-axis at 4. For our final example, let's explore a real-world application that demonstrates the practical power of slope-intercept form. A cell phone plan costs $30 per month plus 10 cents for each text message. We need to find an equation for the total monthly cost using Slope-Intercept Form. Let's define our variables. Let x represent the number of text messages, and let y represent the total monthly cost in dollars. The fixed monthly cost is $30, which becomes our y-intercept. The cost per text message is 10 cents or $0.10, which becomes our slope. The variable cost is 0.10 times x. Therefore, our equation is y equals 0.10x plus 30. The slope of 0.10 represents the cost per text message, and the y-intercept of 30 represents the fixed monthly cost. This equation allows us to calculate costs for any number of texts. For example, if you send 100 text messages, your total cost would be 0.10 times 100 plus 30, which equals $40. Slope-Intercept Form provides an immediate, visual understanding of linear relationships. The slope tells us the rate of change, while the y-intercept gives us the starting value. This makes it incredibly useful for both mathematical analysis and real-world applications. Point-slope form is one of the most intuitive ways to write a linear equation. It directly connects the geometric properties of a line, its slope, and a specific point to its algebraic representation. The point-slope form is written as y minus y sub 1 equals m times the quantity x minus x sub 1. This elegant formula captures everything we need to know about a line. Let me break down each component. The letter m represents the slope of the line, which tells us how steep the line is. The coordinates x sub 1 and y sub 1 represent a specific point that we know lies on the line. Point-slope form is particularly useful in two situations. First, when you know a point on the line and its slope. Second, when you know 2 points on the line, you can calculate the slope first, then use either point in the formula. Now let's work through 3 examples to see how point-slope form works in practice. Our first example will be straightforward. We'll use a known point and slope. Example 1. Write the equation of a line with slope -2 that passes through the point 3, 4. Let's identify what we know. The slope m equals -2, and our known point x sub 1, y sub 1 is 3, 4. Step 1, we start with the point-slope formula. Y minus y sub 1 equals m times x minus x sub 1. Step 2, now we substitute our known values. We replace m with -2, x sub 1 with 3, and y sub 1 with 4. This gives us y minus 4 equals -2 times the quantity x minus 3. Excellent. That's our equation in point-slope form. Now let's move to a slightly more complex example, where we need to find the slope first. Example 2. Write the equation of a line passing through the points 1, 3 and 5, 11. We have 2 points, 1, 3 and 5, 11. Since we need the slope for point-slope form, we must calculate it first. Step 1. We calculate the slope using the formula m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Substituting our values, m equals 11 minus 3 over 5 minus 1, which equals 8 over 4, which simplifies to 2. Step 2. Now we can apply the point-slope form. Using the first point 1, 3 and our calculated slope of 2, we get y minus 3 equals 2 times the quantity x minus 1. Perfect. Notice that we could have used either point in our formula. Now let's tackle a real-world application that shows the practical power of point-slope form. Example 3. A water tank contains 500 gallons at 2 p.m. It's being drained at a rate of 25 gallons per hour. Write an equation for the gallons remaining after t hours. Step 1. Let's identify our linear relationship. We have a starting point of 0 hours and 500 gallons. The slope is -25 gallons per hour because we're draining. Our variables are t for time in hours and g for gallons remaining. Step 2. We apply point-slope form using g for gallons and t for time. G minus 500 equals -25 times t minus 0. This simplifies to g minus 500 equals -25t. This equation tells us exactly how many gallons remain in the tank after any number of hours of draining. The point-slope form made it easy to set up this real-world relationship. Point-slope form is incredibly versatile. Whether you're working with pure mathematics or real-world applications, this form provides a direct connection between the geometric properties of a line and its algebraic representation. Now we turn our attention to the standard form of linear equations. This form has unique characteristics that make it particularly useful for certain mathematical operations. The standard form of a linear equation is written as ax plus by equals c, where a, b, and c are constants. Let me break down each component. A is the coefficient of x and is usually kept positive, b is the coefficient of y, and c is the constant term on the right side of the equation. Standard form has several important characteristics. First, a, b, and c should be integers whenever possible. Second, we typically keep a positive. And third, we avoid fractions in the coefficients when we can. Standard form is particularly useful for several reasons. It makes finding x and y intercepts straightforward. It's also very helpful when solving systems of linear equations. And it provides a clear, standardized way to represent linear relationships. Let's work through our first example. Consider the equation 3x plus 2y equals 6. This is already in standard form, where a equals 3, b equals 2, and c equals 6. To find the x-intercept, we set y equal to 0. Substituting 0 for y gives us 3x plus 2 times 0 equals 6, which simplifies to 3x equals 6, so x equals 2. To find the y-intercept, we set x equal to 0. This gives us 3 times 0 plus 2y equals 6, which simplifies to 2y equals 6, so y equals 3. So our line crosses the x-axis at the point 2, 0, and the y-axis at the point 0, 3. This demonstrates how standard form makes finding intercepts very straightforward. For our second example, let's convert this equation to proper standard form. We have negative 2x plus 1/2 y equals negative 4. Notice that a is negative and we have a fraction. First, we eliminate the fraction by multiplying the entire equation by 2. This gives us negative 4x plus y equals negative 8. Next, we make a positive by multiplying the entire equation by negative 1. This gives us 4x minus y equals 8, which is now in proper standard form. Our final answer is 4x minus y equals 8, where a equals 4, b equals negative 1, and c equals 8. All coefficients are integers and a is positive. For our final example, let's look at a real-world application. A company produces widgets and gadgets. Each widget costs $3 to make, each gadget costs $2 to make, and the total production cost is $60. Let's define our variables. Let x represent the number of widgets produced and y represent the number of gadgets produced. Now we can build our equation. The cost of widgets is 3 times x plus the cost of gadgets, which is 2 times y, equals the total cost of $60. Our final equation is 3x plus 2y equals 60. This is in perfect standard form, where a equals 3, b equals 2, and c equals 60. This equation represents all possible combinations of widgets and gadgets that cost exactly $60 to produce. Standard form provides a clean, organized way to represent linear equations. Remember that a, b, and c should be integers with a positive, and this form excels at helping us find intercepts and solve systems of equations efficiently. Now we'll learn how to convert equations from point-slope form to slope-intercept form. This conversion is essential because slope-intercept form makes it easy to identify the slope and y-intercept of a line. The conversion process involves 3 main algebraic steps. Let's examine each step carefully to understand the mathematical reasoning behind this transformation. We start with point-slope form and transform it into slope-intercept form. Point-slope form uses a known point and the slope, while slope-intercept form directly shows us the slope and y-intercept. Here are the 3 essential steps for this conversion. Each step uses fundamental algebraic properties to isolate y and achieve slope-intercept form. Step 1. Distribute the slope m to both terms inside the parentheses. This uses the distributive property of multiplication over subtraction. Step 2. Add y onto both sides to isolate y. This uses the addition property of equality, which maintains the equation's balance. Step 3. Recognize that we now have slope-intercept form, where the y-intercept b equals negative m times x1 plus y1. This gives us the final converted equation. Let's work through our first example. We'll convert y minus 1 equals 2 times the quantity x minus 3 from point-slope form to slope-intercept form. Here's our starting equation. We can identify that m equals 2, x1 equals 3, and yn equals 1. Our goal is to isolate y and express this in the form y equals mx plus b. Step 1. We distribute the 2 to both x and negative 3. 2 times x gives us 2x, and 2 times negative 3 gives us negative 6. Step 2. We add 1 to both sides to isolate y. On the left, negative 1 plus 1 equals 0, leaving just y. On the right, negative 6 plus 1 equals negative 5. Our final answer is y equals 2x minus 5. We can verify our answer by identifying the slope as 2 and the y-intercept as negative 5. This matches our original point-slope equation perfectly. Our second example involves fractions, which requires extra care with arithmetic. We'll convert y minus 4 equals 3 halves times the quantity x minus 2. Here we have a fractional slope of 3 halves, with the point coordinates x1 equals 2 and y9 equals 4. Let's work through this conversion step by step. Step 1. Distribute 3 halves to both terms. 3 halves times x gives us 3 halves x. 3 halves times 2 equals 3, so we get negative 3. Step 2. Add 4 to both sides. On the right side, negative 3 plus 4 equals positive 1. Our final answer is y equals 3 halves x plus 1. Notice how the fractional slope is preserved, and our y-intercept is 1. Working with fractions requires careful arithmetic, but the process remains the same. Our final example combines negative values with fractions for a more challenging conversion. We'll work with y plus 2 equals negative 2/3 times the quantity x plus 5. This equation has a negative slope of negative 2/3, and both coordinates are written in addition form. Remember that y plus 2 means y minus negative 2, and x plus 5 means x minus negative 5. First, let's rewrite this in standard point-slope form to clearly identify our values. We have m equals negative 2/3, x1 equals negative 5, and y1 equals negative 2. Step 1. Distribute negative 2/3. Negative 2/3 times x gives negative 2/3 x. Negative 2/3 times 5 equals negative 10/3, but since we're subtracting a negative, this becomes positive 10/3. Step 2. Subtract 2 from both sides. To subtract 2 from 10/3, we convert 2 to 6/3. 10/3 minus 6/3 equals 4/3. Our final answer is y equals negative 2/3 x plus 4/3. This example demonstrates how to handle negative slopes and the importance of careful fraction arithmetic. The slope is negative 2/3, and the y-intercept is 4/3. Remember these key points when converting from point-slope to slope-intercept form. Always distribute first, then isolate y. Pay special attention to fraction arithmetic and negative signs, as these are common sources of errors. Now we'll learn how to convert equations from slope-intercept form to standard form. This conversion is essential when we need to work with systems of equations or find intercepts more easily. We start with slope-intercept form, y equals mx plus b, and we want to convert it to standard form, ax plus b equals c. The conversion process involves 4 key steps. First, we start with our slope-intercept form. Second, we move the x term to the left side. Third, we ensure the coefficient of x is positive. Finally, we clear any fractions to get integer coefficients. Let's start with our first example. We have y equals 3x plus 5. We need to convert this to standard form. Step 1, we subtract 3x from both sides to move the x term to the left. This gives us negative 3x plus y equals 5. Step 2. Since we want a to be positive, we multiply the entire equation by negative 1. This gives us 3x minus y equals negative 5. This is our final answer in standard form. For our second example, we have y equals 2/3 x plus 4. This involves fractions, so we'll need to clear them. Step 1. We move the x term to the left side, giving us negative 2/3 x plus y equals 4. Step 2. We multiply the entire equation by 3 to clear the fraction. This gives us negative 2x plus 3y equals 12. Step 3. We multiply by negative 1 to make the coefficient of x positive. Our final answer is 2x minus 3y equals negative 12. For our final example, we have y equals negative 5/4 x minus 3 halves. This is more complex because we have negative fractions with different denominators. Step 1. We add 5/4 x to both sides. This gives us 5/4 x plus y equals negative 3 halves. Step 2. We multiply the entire equation by 4, which is the least common denominator. This clears all fractions and gives us 5x plus 4y equals negative 6. Since the coefficient of x is already positive, this is our final answer. Remember these key points when converting from slope-intercept to standard form. Always move the x term to the left side first. Make sure the coefficient of x is positive. Clear any fractions by multiplying by the least common denominator, and ensure your final form matches ax plus b equals c. Now we'll learn how to convert equations from standard form to slope-intercept form. This conversion is essential because slope-intercept form makes it easy to identify the slope and y-intercept of a line directly from the equation. We start with an equation in standard form, where a, b, and c are constants, and we want to convert it to slope-intercept form, where m is the slope and b is the y-intercept. The conversion process involves three main steps. Let me show you each step clearly. Step 1, we begin with our equation in standard form, ax plus by equals c. Step 2, we isolate the y term by subtracting ax from both sides. This gives us by equals negative ax plus c. Step 3, we divide everything by b to solve for y. This gives us y equals negative a over b times x plus c over b. In this final form, we can clearly identify that the slope m equals negative a over b and the y-intercept b equals c over b. Let's work through our first example with a straightforward conversion. We'll convert 2x plus 3y equals 12 from standard form to slope-intercept form. We start with 2x plus 3y equals 12. Our goal is to isolate y on the left side. Step 1, we subtract 2x from both sides. This moves the x term to the right side, giving us 3y equals 12 minus 2x. Step 2, we divide everything by 3 to isolate y. This gives us y equals the quantity 12 minus 2x, all divided by 3. Step 3. We can separate this fraction into two parts, 12 over 3 minus 2x over 3. Simplifying, we get our final answer, y equals negative 2/3 x plus 4. This is now in slope-intercept form, where the slope is negative 2/3 and the y-intercept is 4. Our second example involves negative coefficients, which requires extra care with signs. We'll convert 4x minus 2y equals 8. We start with 4x minus 2y equals 8. Notice the negative coefficient in front of the y term. Step 1, subtract 4x from both sides. This gives us negative 2y equals 8 minus 4x. Step 2, we divide by negative 2. This is where we need to be careful with signs. We get y equals the quantity 8 minus 4x, all divided by negative 2. Step 3, we distribute the division by negative 2 to both terms. This gives us 8 over negative 2 minus 4x over negative 2. Simplifying, 8 divided by negative 2 equals negative 4, and negative 4x divided by negative 2 equals positive 2x. Our final answer is y equals 2x minus 4, where the slope is 2 and the y-intercept is negative 4. Our final example involves fractions in the result, which is common in real applications. We'll convert 3x plus 5y equals negative 15. We start with 3x plus 5y equals negative 15. Notice we have a negative constant term. Step 1, subtract 3x from both sides. This gives us 5y equals negative 15 minus 3x. Step 2, divide everything by 5. This gives us y equals the quantity negative 15 minus 3x, all divided by 5. Step 3, separate the fraction into two parts, negative 15 over 5 minus 3x over 5. Simplifying, negative 15 over 5 equals negative 3, and we can rewrite this as y equals negative 3/5 x minus 3. The slope is negative 3/5 and the y-intercept is negative 3. Let's review the key points for converting standard form to slope-intercept form. Always isolate the y term first by moving the x term to the other side. Be especially careful with negative signs when dividing. Remember that in the final form, the slope equals negative a over b, and the y-intercept equals c over b. Finally, always simplify fractions when possible to get the cleanest form of your answer. Now we'll learn how to convert from standard form to point-slope form. This conversion requires a two-step process that builds on what we've already learned. Converting from standard form to point-slope form requires two distinct steps. First, we convert the standard form equation to slope-intercept form to find the slope. Then, we choose any point on the line and substitute into the point-slope formula. The process flows from standard form ax plus by equals c to slope-intercept form y equals mx plus b, and finally to point-slope form y minus y sub 1 equals m times the quantity x minus x sub 1. For our first example, we'll convert the equation 2x plus y equals 5 from standard form to point-slope form. This is a straightforward case that will help us understand the process clearly. Step 1. We need to solve for y to get slope-intercept form. Starting with 2x plus y equals 5, we subtract 2x from both sides to get y equals negative 2x plus 5. The slope is negative 2. Step 2. Now we choose any point on the line. Let's choose x equals 1. Substituting into our slope-intercept equation, y equals negative 2 times 1 plus 5, which gives us y equals 3. So our chosen point is 1, 3. Substituting our slope of negative 2 and our point 1, 3 into the point-slope formula, we get y minus 3 equals negative 2 times the quantity x minus 1. This is our final answer in point-slope form. For our second example, we'll work with the equation 3x minus 2y equals 6. This will involve fractions, which requires extra care in our calculations. Step 1. Starting with 3x minus 2y equals 6, we subtract 3x from both sides to get negative 2y equals negative 3x plus 6. Then we divide everything by negative 2 to get y equals 3 halves x minus 3. Our slope is 3 halves. Step 2. Let's choose x equals 2. Substituting, y equals 3 halves times 2 minus 3, which equals 3 minus 3, which equals 0. Our chosen point is 2, 0. Our final answer is y minus 0 equals 3 halves times the quantity x minus 2. Notice how we can simplify this to y equals 3 halves times the quantity x minus 2. For our final example, we'll work with 4x plus 3y equals 12. This equation has larger coefficients, which will give us practice with more complex fractions. Step 1. From 4x plus 3y equals 12, we subtract 4x to get 3y equals negative 4x plus 12. Dividing by 3 gives us y equals negative 4/3 x plus 4. The slope is negative 4/3. Step 2. Let's choose x equals 3 to make our calculation easier. When x equals 3, y equals negative thirds times 3 plus 4, which equals negative 4 plus 4, which equals 0. Our point is 3, 0. Our final point slope form is y minus 0 equals negative 4/3 times the quantity x minus 3. This can be simplified to y equals negative 4/3 times the quantity x minus 3. Remember these key points. Always convert to slope-intercept form first to find the slope. Any point on the line can be used, so choose x values that make your calculations easier. And always be careful with fraction arithmetic to avoid errors.